Hello, everyone. First, I have to give the common warnings. I talk very fast, so if anyone has trouble keeping up, you can just wave your arms, and I won't take any offense. But also, I'm notorious for making presentations that are far too long for the slot allocated to me. So maybe this is a small advantage that I'll be talking fast. So we'll see. We'll see how it goes. Yeah, I wanted to, the title here is How Polkadot Builders Are Pushing the Boundaries of Web3. And really kind of the way I wanted to approach this was by telling you all the decisions that we've made in Polkadot to push the boundaries of Web3, and also how you can evaluate and think about these decisions yourself so that you can go around to this ecosystem, and I'm talking about the general blockchain ecosystem, and see how other people are building, how they are pushing the boundaries as well. I think what's really cool about ETHDenver and a lot of the ETH events is that they're kind of becoming less and less ETH-centric. They're more about Web3, more about blockchain, more about what we're trying to build here, right? And so I don't want to present to you just, this is what we're doing, just blindly believe us. I want you to actually walk through and think about the decisions we make and know that there are other people out there making decisions too. And all decisions have some kind of trade-offs. So yeah, that's kind of the framework here. I want you to leave more equipped to ask why and figure out the answers to what kinds of things are happening. So that's why my presentation is going to be called The Decisions of Polkadot, okay? So first I want to talk about the decision-making process, right? This is kind of my view, not my view, but this is what I've been using as a framework to really help me think about and make my productivity higher. Jeff Bezos, of Amazon, in one of his letters to Amazon shareholders, described this invention machine he wanted to create within Amazon. And how he used two different categories of decision-making, type 1 and type 2 decisions, to help accelerate the process of creating an invention machine. In his words, some decisions are consequential and irreversible, or nearly irreversible, one-way doors. And these decisions must be made methodically, carefully, slowly, with great deliberation and consultation. Oh, there you go. If you walk through and don't like what you see on the other end, you can't get back to where you were before. These are type 1 decisions, okay? And on the contrary, on the other side, type 2 decisions. But most decisions aren't like that. They are changeable, reversible. They're two-way doors. If you made a suboptimal type 2 decision, you don't have to live with that forever. You can reopen the door, go back through. Type 2 decisions can and should be made quickly by high judgment individuals and small groups. So in the context of blockchains, type 1 decisions are kind of decisions that cannot be easily changed in the future. These are original parts of the protocol design, and changes to that must ultimately be like changes to the protocol. And I think this is one of the traps commonly in the space. We have a lot of names of protocols, things like Ethereum, Polkadot, Solana, Cosmos, etc. But these are just names. What we actually mean by those names are underlying protocols, and a lot of these different teams are starting to realize and make decisions about certain things. And of course, you can keep the name and change everything underneath it. And is it the same thing? This is like kind of the ship of thieves, right? So what I'm really thinking about is not the name of products, but actually decisions those products are making, right? And so any changes to type 1 things might as well be new protocols themselves. Whereas type 2 decisions are very easy. They can be changed easily in the future. They can be experimented with, can be played around with. And these are the kinds of things where protocols can delay the decision-making process and add it. And instead, changes to these kinds of decisions can be considered an evolution of the protocol itself. So that's just, I think, a high-level way of thinking about the decision-making process, especially in the context of blockchains. And one more piece I wanted to add, and we'll address this at the end of my presentation, is the format for discussing decisions. Like, I think when you go up to someone, and anyone here at any protocol, they're going to tell you why their blockchain is the best, why the decisions they made are the best decisions. I think that you should use this kind of framework to understand, okay, well, what kind of decisions did they make? Are the ones that they're pitching to you type 1 or type 2 decisions? Can other protocols easily add, change, or modify those decisions in the future? What trade-offs did they make? We all work in the same physical space. It can't be that one team is doing something 100 times faster than another team. The physics doesn't work that way, right? We have the same computers, the same internet, same technology. What are the things they're actually doing? What are the trade-offs that they're not telling you about? And where as a blockchain community do we still have to improve on the decisions, right? Like there might be things that we today do not have the tools to actually implement, right? What kinds of things are those things? So we'll get to this at the end, but these are the kinds of ways I want everyone here to talk about Polkadot and other protocols, really make decisions about and understand what decisions were being made, okay? So as I go into what the decisions of Polkadot are, first I want to tell you the philosophies of Polkadot. Right? Where are we coming from a philosophical standpoint? Well, the first one is less trust, more truth. This is the catchphrase of the Web3 Summit, and if you know some of the details of Polkadot, it was originally proposed, the Polkadot protocol, by the Web3 Foundation. But really, what we're really doing here in the blockchain space is trying to take systems which rely on trust and use technologies like blockchain and other Web3 technologies to turn them more into truth. What we have found in the past is that systems which rely on trust are easily taken advantage of. They are exploited, and they're oftentimes, we as individuals are left holding the bags, right? Like, I mean, we can think about banking crisis and even like, other pandemics and other situations around the world. Trust is something that's being taken advantage of. And so if we can create systems which rely more on truth, allow you as an individual to verify that things are correct and things are happening the way they are, that is better for everyone. Next is a bet against blockchain maximalism. So, one of the sad things I see in this space is that because all these blockchains and cryptocurrencies are tied to some token, you may be a token holder. If that token goes up, you make money. If that token goes down, you lose money. It really causes people to be maximalists. They say, hey, I invested in this thing 10 years ago. I don't care what happened the last 10 years. I want this thing to succeed. I want this token to go up. And this really forces us to be blinded by true innovation, true progress. We have to remember that the goal of this space is not to make the biggest number. It's to actually innovate and make systems which have less trust, more truth, right? And in order to do that, we need to accept the fact that there will be many different blockchains in the future, that the space will constantly be evolving, and that we should be against and pushing away from people who try to push this blockchain or chain maximalism idea. Polkadot is very much against this idea. We want to build a multi-chain future, right? And finally, the best blockchain today will not be the best blockchain tomorrow. This one's a little bit more, I don't know how to say it, it's more philosophical. I mean, I think that the most common philosophy people accept in their mind in this space is this code is law, right? And I think there are some benefits to code is law, but I think the truth is that these technologies and these systems are fundamentally tools for humans to use. And humans change and evolve. Like, our society today, and our society 10 years ago, and 100 years ago, and 1,000 years ago have vastly changed. These blockchains are supposed to be systems which last for hundreds and hundreds of thousands of years, right? Truly like unstoppable machines. It would be wrong, I think, to assume that what we build today is going to be correct for the needs of tomorrow. We could build the best blockchain today, and we're gonna wake up tomorrow and someone else is gonna build something better, because there's gonna be different needs, different things happening in the world. So Polkadot very much at its core philosophy has the idea of evolution, progress, upgradability, and knowing that we're not trying to build a single product that is good today, but a set of protocols and ideas which can evolve over time with the society that we live in, right? Okay, so now we talk about philosophies, let's talk about goals. Okay, so what is Polkadot trying to achieve? Well, I think this is the most common problem in the blockchain space, right? The blockchain scalability trilemma, right? Basically, we're trying to create systems which have maximum decentralization, security, and scalability. But we know that these three things are very hard to mix together, right? If you make things more decentralized, often it can be harder to scale because these systems become more complex, right? If you try to increase security, it may also be hard to scale because you need to make things more robust. If you increase scalability by giving up things like security, decentralization, you start to push things like, are you actually building a blockchain, a Web3 system, or are you just building a fancy database, right? This trilemma is very hard to navigate, and I think really when you talk about any blockchain in the space that's holding any weight, they have some approach to solving this trilemma, some combination of tools, ideas, methodologies that they want to use. So what is Polkadot's mission? Polkadot's mission is to provide secure, scalable, and unstoppable infrastructure for Web3 applications and services. Now, note in here, I changed from the trilemma, which was decentralization, to unstoppable. I think there is something to note about the two. A lot of people say decentralization is the goal, but I would argue decentralization is not the goal. Decentralization is a tool. The goal is unstoppability. What we try to do by creating decentralized systems is make it so that there's no single point of failure. There's no single point of attack where people can take down and stop a system. It is not inherently the goal to decentralize to infinity, right? It's not the goal that every single person in the whole world is going to have a full blockchain node running at their home. but we want to reach a certain level of decentralization which can allow for unstoppability. So that's why in here the mission is not decentralization as a goal, but unstoppability. Trying to get to a point where Polkadot, the system, cannot be taken down by individual actors. So we try to accomplish this mission by solving 3 problems: computational scalability, shared security, and interoperability. And I'll go through all these things in our decision-making processes. So yeah, so now we have talked about the philosophy, the goals. Now let's talk about the decisions. Using this framework, we now have to make a bunch of decisions on how we're going to build and design a protocol to satisfy these requirements, right? And this is where, again, this is our opinion. We have made trade-offs here. We're not claiming that every single decision here is perfect for every scenario. But these decisions make sense for us, and given no better knowledge of other solutions, these are the ones we picked. Now, the decisions I'll go through are mostly type 1 decisions. These are decisions, again, that are a core part of the protocol. You have to make these decisions up front. You cannot skimp on these decisions and make them later. A lot of protocols today, in my opinion, are trying to push the hardest problems to something they'll figure out after the fact, and instead just try to make something that kind of works, something they can launch their token with, sell it to you, and say, hey, we'll handle that later. But the truth is, a lot of these decisions need to be made up front. Otherwise, it's not the same protocol. Otherwise, you're not building the same thing. Otherwise, the things you're trying to build cannot actually change, be upgraded to actually solve the problems you want. So let's talk about our decisions. The first one is WASM. Now, this is, I think if you're in the Polkadot space, you hear the word WASM a lot, but I still don't think it's actually as emphasized, the importance of WASM, as it really is. WASM is a key backbone of Polkadot. It is a meta protocol which establishes how all of the execution of our state transition functions of our chains in our ecosystem are run. It standardizes how chains execute, and it allows us to use any programming language which can compile to WASM to be used in our ecosystem. And you'll see in the other decisions we make how WASM is being used. But I will really say this to you, a belief in Polkadot is a belief in WASM, and WASM is a really exciting technology, which I still think we're on the very early beginning of in our space. So the first one is sharding. So I think it's funny, this doesn't come up enough. What is Polkadot's #1 way of scaling? It's through parallelization. But to achieve parallelization in blockchain is actually very complex. As you might know, imagine there's 2 balance transfers happening. They're both targeting me. I'm getting, let's say 10 DOT from one person, 5 DOT from another. If I try to parallelize these transactions, you have, these race conditions, right? Where basically, when you write this to the database, how much balance you should actually have, you have 2 different writes happening at the same time. My balance is not going to get updated correctly. This is a common problem in databases in the real world. The real way you can actually scale and parallelize transactions is by sharding, by keeping data separate from one another, which means that any data shard can, those transactions touching that data shard can be parallelized, right? Because we know that the data is being separated and not being touched at the same time. So really, Polkadot's #1 scaling solution is parallelization through sharding. Now, there are other blockchain systems out there which are trying to do optimistic parallelization or some other stuff like that. Optimistic stuff doesn't work in blockchain. We are building systems that are where every user is assumed to be an attacker, right? So the only way you can truly achieve parallelization, which is a very strong scaling solution, is through sharding. And you'll see that there are other blockchains out there which are also looking into sharding. It's even part of the Ethereum 2 long-term roadmap, right? The next one is app chains. This is another key decision. We have these different shards. We call them parachains. You can treat them basically as individual blockchains. All of their execution can run parallel to one another. But we've also made a key decision that we don't assume that these different shards are the same blockchain. We assume that each of these different shards can have their own individually customized logic, which can run a unique service or application for the end developers. We call these app chains. And this is where the word heterogeneous comes from. So if you heard Polkadot is a heterogeneous sharded network, the fact that we allow each of these different shards to be different is what allows this app chain idea. And this is really the belief that there are many different solutions or problems to be solved in the blockchain space, and that the ability to specialize your solution will allow for greater performance to the end user using that product, right? You could, of course, build a general VM, something like the EVM or other smart contract platform, and you could, of course, build hundreds of different applications on that one VM. But the truth is that probably none of those applications will be optimized for that VM environment. Instead, if you could build the whole stack, your whole shard, with an application in mind, you can actually create primitives and security layers and a whole bunch of other unique, interesting things which are optimized for your specific application. Okay, now moving on to interoperability. So we have all these different application chains. They're all working in parallel with one another. It's not going to be useful that these applications just exist in separation, right? Like right now, we fortunately in our space today, we have the use of a lot of centralized exchanges to kind of act as an interoperability layer between these different separate blockchains. But if we're trying to build a multi-chain protocol, we must, of course, at the root of our decision-making process, think about interoperability, how these different applications will inherently talk to each other and work together to create full-fledged end-to-end solutions, right? There might be one shard doing identity problem, might be another shard doing a governance problem. You're going to want to be able to interact with those two things, so your governance system can look at identities, make sure that there's like Sybil, or you're de-Sibylling users or doing other kinds of reputation checks, and make sure that these end-to-end systems work well together. And our interoperability stack is composed of two pieces. And notice one of these are type 2. The type 1 decision is XCMP. This is a general message passing protocol across the different shards of Polkadot. This allows general messages, opaque blobs, to be sent between different parachain shards and allow them to communicate with one another. Now, these opaque general messages aren't very useful. What we also need is some kind of message format that everyone understands and everyone can use. And I'll note that this is a type 2 decision. XCM, the specific message format that we've kind of coined in our space, is something that can change, can evolve, could be thrown away and replaced by something else. But it makes it very useful to have a shared message framework, message format, to use over this general layer. But what is important, what is a type 1 decision, is the fact that we, from the beginning of our protocol, have designed the ability for these different chains to communicate with one another. How and what they actually communicate, we don't care. But the fact that it exists is a very key and important idea for Polkadot. And finally, shared security. One of the often overlooked problems in this space is economic scaling. How else I say this? We talk about security of blockchains a lot. We know that there are blockchains out there which are getting attacked, like Ethereum Classic, Bitcoin Cash. These are chains with low relative security because they're small chains. They don't have big mining pools. Same with other proof-of-stake chains, right? These chains with very small economies, it's very easy or cheap to attack them. If we believe there will be hundreds, thousands, tens of thousands of blockchains out there, we must think about how will these blockchains secure themselves? How will there be enough economic backing on all these blockchains to make sure that all of them are secure? And if we're going to have them interoperate with each other, we need to make sure that they're all equally secure. Otherwise, a way to attack the whole system is through the weakest entry point, right? If you say, okay, well, the average, top 50 blockchain is probably like $1 billion market cap, and you have 10,000 blockchains out there, I mean, just do the math. That's like a $10 trillion problem. The blockchain space right now, all the market cap of all coins is only around 2 trillion, 1 trillion. I don't know the exact price right now, right? But if we want to continue to secure more and more chains, we need to solve the economic scaling problem as well, right? And so Polkadot does this. Polkadot does this through shared security. And this has been part of the initial white paper. Since 2017, we've been solving this problem. We've had in mind this economic scaling problem. And it is unique in Polkadot that when you join as a parachain, you get the same security that Polkadot itself provides. So whatever economy that Polkadot has built up around itself, it can share that with all the different parachains in the entire ecosystem around Polkadot. This also allows for one more thing. Through shared security, you have this trust-free interactions. I have a talk tomorrow. I have a talk tomorrow that you can go to. I have a link to it. But basically, trust-free interactions is the fact that you have all these different parachains on Polkadot finalizing together with the relay chain. This not only allows these different individual chains to be secured by Polkadot and have the same economic security, but it allows that any interactions between chains are also finalized in tandem with the relay chain. This means that if you have two different chains talking to each other, and they're transferring tokens and doing whatever, that those operations are happening and being finalized by Polkadot itself. You don't have to worry that one of these chains will roll back, because in order for that chain to roll back, your chain will have to roll back as well. When you have normal bridges, like these non-shared security interoperable layers, like for example just a bridge, you have to worry that a separate blockchain has its own consensus, has its own finality, and can choose to roll back, can choose to go backwards, and that could put your chain, which interacted with the other chain, at a problem, right? What if they decided, hey, actually, we didn't transfer that token, but then you on your side say, hey, but you did give me the token. Now you have a consensus issue across two different chains. This isn't a problem because of the way that Polkadot works and secures all the chains together under a shared security umbrella. And so shared security really is actually a bunch of pieces together. I talked about WASM already as a key backbone of Polkadot, but to provide shared security, you need to have a combination of things like WASM, the parachains protocol, which is this advanced system within Polkadot which makes all the parachains work, shows how they interact, shows how that they prove their state, actually verify it, everything, and the existence of the relay chain itself. I promise you, you're gonna go out there today, and you're gonna hear a lot of people talk about how they're trying to solve the shared security problem. And I'll tell you this, my belief, if they don't have all the pieces like this, it doesn't have to be exactly this, but like this, for example, a beacon hub or a settlement layer, which is the relay chain, a protocol built into the thing to be able to satisfy and verify all these functions, and some kind of meta protocol to make things easy to interoperate with each other, then they aren't doing it right. And again, this is why this is type 1 decisions. These are things that need to be thought about at the beginning of the protocol, not bootstrapped after the fact. So anyway, if you want to know more about shared security, I have a talk, not tomorrow, I guess March 2nd, that's 2 days from now. And you can see I'm going to go a little bit deeper into shared security and talk more about it, which I couldn't cover today, didn't have time. Okay, other key type 1 decisions. Hybrid consensus. We have decided within Polkadot to separate our block production and finality. This allows for chains to continue to produce blocks even when there might be finality stalls. Now, finality stalls don't happen often, but it's a common part of life. For example, if there are network issues, if for what example, the internet between Asia and North America got cut, it's nothing we can do about that. This is physical problems in the space. But how our blockchain reacts to those problems is very important. What we've decided by separating these two different processes together is that our blockchain can continue to exist, continue to create blocks. It will continue to move forward, which is the key part of making useful and interactive applications. But it might be that finality takes longer to actually resolve. But that's okay, because the process is separated. We allow it that the block production can be creating many blocks, many forks, and that we will eventually get to a finality saying which is the actual canonical chain of Polkadot. Another key type 1 decision is a light client first mentality. We have made many decisions within Polkadot which have constantly placed the importance of light clients as a part of the future of Web3. Now, this is one of those things, again, if you do not design your blockchain with light clients in mind, it'll be very, very, very difficult to add that after the fact. If you, like me, believe in trust-free systems, more truth systems, you definitely want to interact with a blockchain through a light client. You do not want to connect to Infura or some other centralized node and assume that what they're telling you is correct. You want to be able to have your own mobile app and know that I'm interacting and doing things with proofs. I'm able to verify the actions I'm taking, the information that's being provided to me. And that is a key part of the light client stuff. And we've made decisions which have made Polkadot, some could argue, slower or more complex, certain kinds of data structures which are needed, like Merkle trees, but enables things like light clients to exist. And I will tell you this, we have a working light client today. For a lot of protocols out there, their light client is part of their 2-3-year roadmap. Guess what? If they're not designing that already into their system, they've lost. This is a type 1 decision. We have it working today because we've designed it from day 1 to work. You can go, I should get a link for you all, if maybe somehow we can pass a link to everyone. You can literally go to a website today and it will start syncing Polkadot on your phone without any installation of anything, just on a web browser, because of the use of WASM, because of the use of our light client first mentality. Let's keep going. On-chain upgrades, forkless upgrades. So this is another really key decision. Again, we're going back to WASM here. We believe that, I guess it was back to the philosophies of Polkadot. We believe that Polkadot needs to evolve, that blockchains in general need to evolve. through the use of WASM as a meta protocol, we've actually designed our infrastructure such that the client tools we have don't rely on the client binary to actually run the blockchain, but actually a WASM packet, a WASM binary. And this WASM binary is part of the storage of your blockchain, which means that your blockchain, it runs your blockchain by looking into the storage of your blockchain, just like anyone's balance or whatever, reads the WASM code and executes that. And that is your blockchain logic. The difference between Polkadot and Akala and Moonbeam and A-Star and every other blockchain you can imagine on the Polkadot ecosystem is not the client, but it's actually just this WASM blob. You can convert any blockchain to another blockchain by just switching out the WASM. In reality, the Polkadot binary, or the executable, is just some kind of WASM executor. And inside of that lives this binary, which allows us to have an on-chain runtime and to forklessly upgrade chains. We have other talks on this, by the way, if you're interested in this topic. Actually, I'll do a workshop tomorrow where we do a forkless upgrade here in ETHDenver. Okay, on-chain governance. Now, this might not seem like a type 1 decision, but it is. On-chain governance is one of those things where how a protocol makes decisions, once that is established, is very hard to change, right? We look at, for example, the way that Ethereum works. Ethereum doesn't have an on-chain governance system. It has kind of like a soft in-person governance system. You have these developer calls, people get onto the call, they have ideas, they make EIPs, and basically you have a set of voices whoever's voice is loudest, kind of that's the direction in which the technology evolves. On-chain governance, on the other hand, establishes a set of clear, well-defined rules, which is run on the blockchain itself, on how decisions are made. And very importantly, because we have things like an on-chain runtime, the logic of your blockchain lives on the blockchain, you can have on-chain governance actually change and affect what your blockchain logic is. This allows for a definitive, well-defined process for your blockchain to evolve and change over time, because the votes, which happen on-chain, actually will change the things in your blockchain. It will actually change the code of your blockchain. Whereas, for example, other off-chain governance systems, you have a call, they agree on some proposal, they agree on some EIP, and then what happens? Then you actually start developing. Then you actually start creating things. And who knows the difference between what people say they want to do and what actually gets implemented? How many other clients, they all will differently implement some kind of solution, right? This makes it very difficult to agree upon and make sure that things are actually happening the way you expect. On-chain governance, it says, hey, I have a new piece of code, you can run it, you can test it, you can see the source code for it, and I want to upgrade the chain to be this. And when that vote passes, that chain actually upgrades. It changes on-chain. This is a very key part, and something that if chains do not have this implemented today, it just won't happen. And again, these kinds of things to enable on-chain governance, real useful on-chain governance, you need to make decisions like having an on-chain runtime, right? And finally, an on-chain treasury. Again, I'm mentioning a lot of on-chain stuff, but it's like, we are trying to move things onto the blockchain. Blockchains are resilient systems. They are systems which drive consensus. They are systems which cannot be or should not be attacked easily. They are not controlled by central actors. So the more we can move on-chain, the more resilient these blockchain systems can be. And another way that we ensure the longevity of Polkadot is by having an on-chain treasury. By having in our protocol a way to fund developers to continue to build and develop on that protocol itself. If you were to look at other blockchains, they might have some initial, when they launch the token, they might have some central foundation which controls a bunch of funds, and that fund distributes the funds to developers and makes things happen. Gosh, there's a million ways this can go wrong, right? You have these foundations, they have their friends. Their friends are the ones getting the grants. The grants are maybe overpaid. The token is worth a little at the beginning, so they spend a lot of it at the beginning, and the token goes up, and they don't have any more funds left. How do they replenish the funds? These are all questions you should be asking in every ecosystem you're in. Polkadot takes 70% of all transaction fees and puts it into a treasury, and that treasury constantly gets spent to the users to continue to develop it. We have a self-sustaining protocol to build and develop Polkadot for the future. And again, that's built in. This is type 1 decisions, right? Okay. So I'm going to move now to type 2 decisions. One I wanted to call specifically was nominated proof of stake. Polkadot, it is a platform for providing shared security. Therefore, the security of our nominators, of our staking system, is very important for the rest of the ecosystem. Because of that, we decided to do more complex proof-of-stake systems. Most proof-of-stake systems you've seen out there are probably delegated proof-of-stake systems. These are simpler to create, better at scaling for sure, but not as efficient at allocating capital. We created a very complex, probably the most complex staking system out there today, which ensures that capital allocation is maximized. It makes sure that you can take a user, they can nominate many people, and within the algorithm of Polkadot, we decide how these funds should be separated so that most of it as possible will get used. And this ensures the maximum security for people in our ecosystem. It is much more complex. Truthfully, it is not as scalable, but for our needs, it is a key decision that we made, and we continue to work on and evolve over time. You might have heard, for example, recently nomination pools and other things we've been doing to evolve NPOS. I'll make a list of other type 2 decisions. Again, I won't go over all of them, but this, we mentioned the type 1 decision is having on-chain governance. The type 2 decision is how that on-chain governance works. We just recently upgraded to a new Gov 2, or Open Gov on Polkadot. The principle of having on-chain governance is there, but the fact that how the governance process exactly works is not super important. We can make those decisions later and evolve them over time. Same with staking, same with integrated multisigs and proxies and batching. How exactly those works, we can evolve over time. How treasury gets spent. So having a treasury on the chain is a type 1 decision. How treasury funds get spent, what the process is to actually spend those funds, those are type 2 decisions. Very different, right? Same with on-chain storage, the XCM format, etc. So really the thing I wanted to have you walk away with is that there are certain philosophies and ideas which you have to have those ideas from the beginning. You cannot just bootstrap them. But thankfully, we can evolve the mechanics of those ideas. But again, many chains out there, I think they don't think about that up front. They think, this is a problem that's kind of complicated now. I'll try to solve it later. I would have you question those decisions. Okay, so I'll close on this with the discussion. So I'm just gonna, I'm not actually gonna have the discussion here, but I'm happy to have it with you one-on-one if you find me. But these are discussions that I would take along with you to other teams, other protocols, other people who are pitching you their amazing ideas, okay? Let's keep going. And again, let's go back to the format for discussing decisions, right? So you go to someone, they say, hey, we built this really awesome new idea, this new consensus algorithm. So what was that decision? What do you need to consider in that decision? Was it a type 1, type 2 decision? What trade-offs did you choose that made that decision? What decisions did other people take? There's a lot of people, really smart people in the space building in the blockchain space. Why did they not decide that decision? And where do we still have to grow and evolve? Are you making a decision that's the best you can do now and you have ideas for the future? Are you setting yourself up to actually evolve those decisions? Okay. So trade-offs, right? So I bet you can go to every single blockchain protocol and ask them, what trade-offs are you making in this trilemma? Are you sacrificing decentralization for scalability? For example, are you promoting on your chain faster hardware versus hardware which is available to consumers? Are you building your blockchain based on the fact that every node is a supercomputer? If so, you're getting more scalability for sure, right? The more powerful computer, the more transactions you can process. But you're also sacrificing decentralization. Can those computers be accessed by towns in Africa? Can be accessed by anyone that's not a cloud provider, right? What are the decisions you're making there? Another one, the consensus, right? Do you have hundreds or thousands of participants in your consensus system, like validators and nominators? Or do you have this 10 or 12, securing nodes that do all the work for the, thing? Of course, you can verify the work that they do, but it's really all decisions are made by 10 or 12 small nodes. Of course, this will increase scalability because there's much less to gossip around, but it's not decentralized, right? Are you sacrificing security for scalability, right? Are you doing things like optimistic computation, optimistic parallelization without sharding? Are any of those systems actually useful, or will they actually work? Probably not, right? But they are sacrificing the security of their network to get some kind of optimistic, best case scenario scalability, which is really not useful. Same with simple block producer selection. A lot of protocols out there, they have a system where you can know for the whole day, every single person who's going to produce a block in which order. Guess what? In order to attack that system, you don't need to attack all the validators. You just need to attack the next 10 block producers, right? That will stall their blockchain for the next minute and a half, 2 minutes, whatever you want, right? And that can cause real problems to the blockchain. When you make decisions like on Polkadot, we actually use a random selection here. So you do not know who the next block producer will be, but they'll be able to submit a proof saying, hey, I am the next block producer. This does not allow for you to attack the network. It increases security, but it obviously is a more complex problem to solve. Sacrificing decentralization for security, right? Having something like a beacon chain or a relay chain arguably could be considered less decentralized. But as you'll learn if you go to my talk on March 2nd, that it actually increases security. And these are the trade-offs that are made perhaps worth it, right? Same with NPOS. So NPOS increases security, but it's not as scalable. It's likely that an NPOS system will not have as many validators or nominators as a DPOS system. Is this a fair trade-off? Decentralization versus unstoppability. How am I doing on time? Am I almost there? Okay, one more second. As I mentioned, it's a little bit long, but decentralization versus unstoppability, right? So imagine certain protocols have a superlinear complexity. What is the line you draw at that things are decentralized enough, right? Like, for example, if you're, how many nodes do you want to exist? Should there really be millions of nodes out there? Millions of validators, nominators, voters? Should there be only 10 nodes out there? Right, somewhere in between, there's a trade-off here. And so when you talk about protocols and they say, okay, well, we have 100 nodes, ask them, is that the number that you want to hit, or is that the number that you can hit today based off scaling solutions? How unstoppable is your system? You could have 100,000 nodes, but if there's, like, for example, centralized points of failure, is it actually unstoppable, right? These are the kinds of questions to ask. Scaling of independent chains. So we obviously know, there are chains out there like Bitcoin, Ethereum, Solana. They're independent chains. They're looking at a lot of independent individual scaling solutions. Cosmos is trying to create independent chains with a shared communication protocol. Ethereum's sharding roadmap, the Ethereum 2, has the idea of a homogeneous sharded network. Polkadot, of course, as I described to you, is a heterogeneous sharded network, right? There are different approaches to scaling these chains. Why did they make those decisions? Go to these protocols, ask them, why is having a single chain the right solution for Solana? Why is having a homogeneous chain the right solution for Ethereum, right? Ask me, why is having a heterogeneous chain the right solution for Polkadot? And I kind of explained that already, right? Upgradability. You have things like Bitcoin. They believe that upgradability, that stability is part of the protocol. It is part of the value add of Bitcoin. It doesn't change, and that is what they like. Ethereum has an off-chain decision process. Polkadot has an on-chain process. There are trade-offs here. I'm not claiming to you that everything is better on-chain, but there are trade-offs, and I question you to ask and figure out what are the actual things that are necessary for an evolving, changing platform. Staking, right? A lot of protocols out there are doing staking. Staking is like the hot thing. Make money for free, right? Do you know protocols which are implemented staking but have not implemented slashing? Ask them, why is there no slashing? What is the value of staking if there is no slashing? Are you just printing money out of nowhere? What value is being generated by your staking process? Are you just staking to make money? Or is there actually some value being accrued through staking? What kinds of incentives are being provided to affect the behavior of participants? What are your choices between using DPoS and NPoS systems, right? And consensus. This is the most technical of topics, right? But if you really get to the right person, you can ask them, right? Like, are you handling your consensus messages on chain? If you know, you know, right? Like, Jesus, that is a bad idea. Block production choices. Are you using proof of work, proof of authority, proof of stake? Are you randomly selecting the block producers? Are you providing censorship resistance through the selection of block producers? Your finality choices. There are protocols out there which claim they have instant finality. Is instant finality actually good? What happens if the finality stalls and you can't make new blocks, right? Are those the right decisions to be making? So anyway, that's the end of my talk. I hope that you will go around to those booths. You'll talk to a lot of protocols out there, a lot of smart people. And I promise you this, every single team out there, outside of Polkadot 2, has some smart ideas. But it's important to understand the trade-offs they're making, the decisions they're making. What are the type 1, type 2 decisions they're making? And what are they actually contributing? Where are they making compromises? Where are they telling you that they are the best where other ones aren't? Don't stop asking why, and use this as a framework to kind of, maybe kickstart those ideas. Okay? Thank you.